Hello everyone, I hope you can hear me. My name is Doganis. I'm with the National Technical University of Athens, and today I will be presenting you the demonstration on the OpenRiskNet approach on modeling for prediction or read-across with the Jaqpot platform. This is part of the ModelRX case study of the OpenRiskNet project. So as we progress, there will be some questions that we would like you to answer in order for us to be able to have a picture of who is attending, what they think of, what they expect. And so please answer. We will be giving you some time for that. And you can also have some questions in the chat window of the GoToWebinar panel. So as we have some ground to cover, I will be starting. We will be first giving you a short introduction about the ModelRX case study, and then we will be showing the versions of Jaqpot, which is our cloud modeling platform. We will be going over the functions, and without further ado, let's start. So our first question is to identify, first of all, who is attending and what their needs are. Where do you do most of your work? Is it experimental, computational, or IT? Okay, so few people do experimental work, most people do computational work, and almost equal are information technology, in the sense that they are the ones that have to construct all the infrastructure for this whole thing to work. Okay, thank you for this. So the work in OpenRiskNet was centered around a risk assessment framework on which we constructed case studies. You see a rather complex diagram on the right-hand side of the screen that we unfortunately don't have time to explain right now, but the juicy part for us now today is the ModelRX case study called Modeling for Prediction or Read-Across, and Jaqpot and the work we will be presenting is part of that. That, of course, involves many, in order for us to have data that we can process. There's the DataCure case study about data curation, the MetaP, metabolism prediction, reverse the RevK for reverse dosimetry and PBPK prediction, the toxicogenomics case study, the sysgroup and systems biology, AOP link in the adverse outcome pathways, and this all is linked as you see. Please refer to other OpenRisk webinars in the OpenRisk website, OpenRiskNet, sorry. There are many webinars that you can consult if you would like to have more information. So the ModelRX case study is, as it is placed within OpenRiskNet, it contributes by providing computational methods that supports suitability assessment of existing data and identification of analogues, and predictive modeling functionalities, which are essential in the field of final risk assessment. This case study is led by Sarimveis here at NTUA, and part of the team are also people from Johannes Gutenberg Universität Mainz and the University of Uppsala. Of course, you can also find more information about that in the OpenRiskNet.org website. The tools that have been made available within ModelRX case study are starting with Jaqpot, which has been built by NTUA. You see two different categories here. Unless you're familiar with them, they mean GUI stands for Graphical User Interface and API for Application Programming Interface. So Graphical User Interface is more or less what people on the street would call a website that has a user interface that they can use, and which in our case has more functionality. And an API is something that allows machines to work with our service. That allows you, for example, to have additional to add this functionality to other tools that can use it behind the curtain and enhance their product offering, their functionality. There are two different versions. There's version 4 and version 5. We will be talking about the capabilities of each version. Right now we're developing version 5. Version 4 is the previous one. And we will be going through these. There's has been substantial work within OpenRiskNet to make Jupyter notebooks that run on the cloud available. And also there is the Squonk computational notebook that allows you to perform calculations online with a nice user interface. You can also find the Lazar tools which offer both an API and user interface. And there's the WCRS service from the University of Mainz, GGU. You see it here. And the University of Uppsala has produced 3 API instances that are called MetPred, CPSign, CPLogD, that are dedicated to predicting specific functions and performing and calculations that help you with some work. So the first question, the second question that we were going through right now is, how would you rate your experience level in modeling of chemicals, from no experience to experienced? Okay, so now that the poll is closed, there are mixed results. But actually, I don't think that is a problem in our case, because we have people with no experience, we have people that occasionally have performed modeling, and there are people that have some experience, that are experienced. So what I find that makes Jaqpot suitable for use in this implementation is that it can offer functionality on many levels, and it can also give something for the non-experienced user, and can give access to modeling functionalities with a smoother learning curve. It can offer tools to the occasional user, and it can also be a valuable tool for fast implementations and easy integration to the experienced user. So let's move on. Jaqpot, first we need to define it more specifically, because that will make the discussion smoother. It is a web application for modeling. It offers functionalities for data pre-processing, and also there are algorithms for statistical analysis, data mining, and machine learning. There are a variety of algorithms. What we find very effective is that through the implementation of what we call the JPDI, the Jaqpot Protocol for Data Integration. It has become possible for us to integrate algorithms from actually any language. What only matters to us is that there is a common protocol for exchanging data. So right now, within Jaqpot, there have been integrations of algorithms in Java, in Python, in R, and virtually anything can be integrated as long as it sends the input data and accepts the input data and sends its output in a defined way that we can read and collaborate with. And also, more specific for this domain, there are methods for defining the domain of applicability of a predictive QSAR or nano-QSAR model. The domain of applicability, I must note, is an important factor in models because it allows people to get a sense of how much trust should be given to a calculation. Jaqpot has been developed following the extended OpenTalks APIs, and it offers modeling and in silico capabilities. Jaqpot 5 was a step that we took in order to expand the modeling functionality of Jaqpot 5. And within it, we have added QPRF support. And gradually, we are adding some more features from Jaqpot 4. So if we would like to see a comparison chart between them, both offer modeling functionalities. There is validation capability in both of them. Of course, I must note that a big step in Jaqpot 5 was the integration of all scikit-learn algorithms, and the QPRF report has also been integrated in Jaqpot 5. What was included in Jaqpot 4 was the QPRF report, which will be added. And in Jaqpot 4, as I mentioned, over the JPDI, we had integration with Python, and also I must note here that in the last column, the second row should be that we had integration with R over the JPDI, and there were some additions that we wanted to make, but also it should be / over JPDI. The final line here, what is an important step in Jaqpot 5 is that we implemented what we call the Jaqpot Pi, which is a package that can be installed by pip and allows people to use Jaqpot through Python code. We will see how that looks in the end. And also, we are taking steps into integration of R into Jaqpot 5. So in terms of infrastructure, I must note that the following elements, the elements that we see have been used. Dockers in order to Docker has been used in order to run containers. OpenShift in collaboration with Red Hat has been implemented here. Also, we have Keycloak and OpenID Connect, and solutions like Kubernetes has provided a very nice framework for our solution here, and has been critical to the OpenRiskNet infrastructure. Moving on to the presentation of Jaqpot 4. This is the initial screen that we see. It offers many functionalities, and if someone goes to the first thing that someone would do would be to click to go move the pointer to the top left of the screen and go to sign in or create account. That would take the user to this screen where either a new registration has to be made or a login is done. So a user that has logged in has access to resources that are personal to him or her, and are models, algorithms, datasets, reports that have been created, or others that we will not go through for now. The algorithms that are offered within, so the algorithms that are offered here are these. They're both regression and classification algorithms. As we said before, they are implementations in Java and Python, and also from R, as you see, a linear model from R. It is important that the algorithms are already annotated ontologically. For example, if we took a look at the scaling algorithm, we have annotated them according to the OpenTox ontological classes. You find the link to the OpenTox algorithm ontology on the bottom of the screen. And there are different classifications, different classes for the other ones, the WCAMLR and, for example, the Python ID3 with MCI algorithm. So we will be going through an example of model training. We will be studying a problem for the solubility of C60 fullerene in various solvents by Garagesi et al. And we have made available the data set, the full data set and the training data set. So in order to start this process, one would need to have, one can follow two routes. One is, as we show on the screen, point number 1, and the other one is box number 2, which train a model, or going through the center of the screen and clicking train, that takes you to the same screen. So the first thing the user is required to do is to train a data set, to select the data set in question, which in our case is highlighted. It is a data set with 5 descriptors and solubility for 93 solvents, the training data set. Then the user chooses the algorithm. Right now we will use the linear regression by Python. And this is where we define the algorithm parameters. The user needs to fill in the title and the description of the produced model. This is the model name. We on the left-hand side, you see a more detailed model description. Usually, it makes sense here to provide the full reference, a full citation to the publication you are referring to, or or if you'd like to, unless it's it's work that you're still that hasn't been published. You write something else that is descriptive to you. Of course, this is only can only be seen by the user that does this. So the next step would be to go to the right-hand side and select the input variables that will be used for the model and the endpoint. As we see here. And another thing, another way to go about this is to select the endpoint only if one would like to use all other variables as input variables. I should note here, it's more apparent here, more easily visible here, that there are also choices to go through these functions with PMML files. If you are available, if you know these, they are for repeated actions that you would, they make sense if it's something that you would repeat, but they or allow you to define the variables that you will use in the model and in a predefined in a file that you upload or have already in Jaqpot. That also allows you to make to define any new variables that you would like to be created by performing mathematical operations on the variables that you upload in the dataset. So additionally, one chooses any scaling options. Right now we will choose scaling between 0 and 1, and whether domain of applicability calculations are desired. That leads you to this. This is the task screen, and this gives you an insight of how things work here, because tasks can have a rather long duration sometimes. The tasks are asynchronous, so you need to, they are managed within Jaqpot in that way, so it takes some seconds for them to be for that button that we see here, the see result button, to turn red, which means you can move on. That takes you to the model web page, which is what it looks like. This gives you full information about the title and the description of the model. Actually, this is what the user has entered before, and also any possible transformations that have been used, the domain of applicability. We did please remember that we performed some scaling, and also you get information about what you need to add in the model, what you get as output, and you get access to what you can do with the model. You can validate the model by which is what we will see in the next screens, or make predictions. Okay, so that can be done in one way by inserting the values manually. If you choose in the next screen, if you go to the insert values, which is has been selected as blue here, you can copy paste in the respective columns your values for any dataset that you would like, and click validate. Or otherwise, you would choose a dataset as we saw before. That would lead you to the validation report here, and this gives you information about, of course, what this is. This is an external validation report. Please remember that there are additional kinds of validation type schemes that we can use, but this is an external one that we have access to from the model web page. You have access to the ID of the model, the ID of the dataset that was used to construct this, the algorithm type, F values, the R squared according to OECD, and all the data. What is nice is this button here, the download button. Please remember that. We will be revisiting that, and you can see the real versus predicted values, and also a QQ plot, and the real versus predicted values plotted here. That button that we saw before, that red button, allows us to download this report as a PDF. And this is what its beginning, the first of 7 pages, would look like. Actually we get the information that we saw in the validation report. Another thing that we can do from the model web page is to get predictions, and this is what we would get. The predicted value in the the number of the compound, the predicted value in the next column, and the leverage, the domain of applicability according to the leverage method here. And for each one, you can get, for each prediction, you get a QPRF report. And it stands for Q-sharp prediction reporting format, contains all the fields required by OECD guidelines, which means you can add information about the substance, the general information, the prediction that you've made, the adequacy. This is the template that you can fill in and, of course, download in order to disseminate to anyone that you would like. This also accompanies, this graph also accompanies the QPRF report that shows you a PCA, principal components analysis of these values that you have versus the QPRF query values. This report, as we said, is downloadable as PDF, and what we mentioned before is the additional validation schemes that we have access to. Right now, we've seen the last one, the external validation, which is validation with an external dataset, and we also have access to cross-validation and data split, where we split data into training and test datasets according to a split ratio. Okay. So this is Jaqpot 5. It is a new version of Jaqpot. It has a different user interface, and what we gain from this is different functionalities. Of course, in order to move on with the description, one would have first to log in. One would need to log in, and this is possible using your Google account or your GitHub account, or you can set up using your email. Okay, so right now, what you would have your home screen, your starting screen. If you are a user that has been logged in, this is what you get. It shows you a quick view of all the resources that you have access to, whether it be it may be datasets or models. So if you click on the three stripes here, what you would see is the menu that gives you access to, that takes you to the home, gets you to the model and the models that you have, and maybe for future time, we will have time to describe in another occasion apps that are here under development. Sorry, when you select a resource here, it shows you get additional information on the right of your screen, this section. It shows who created it, when, and the description that you added, the description data. Also, what you get in your shared space is if you click on Models Mine, it shows you initially your models that you have. But if you click on this arrow here, you get access to the shared. And there are many shared categories that you can see. Actually, here, right now, we see a first example of the presence of organizations within Jaqpot. So resources, models and data sets can be shared within organizations. So you have, so to say, groups of users that can share can share resources among them and collaborate. This is an important feature, and right now we see what we get, what I am sharing with others as an OpenRiskNet user, part of the OpenRiskNet organization. So the view of a model is different in Jaqpot 5, and this is what it looks like. You have more power to annotate things and add your links. And also you have access to define the QPRF report here according to any to specific instructions that you need to adhere to. But that information that can also be downloaded as a PDF as a report. That is really a handy tool that allows you to accompany any predictions you make with the QPRF report of the model. So on the bottom right of the screen of the model, we see a pencil. If we click on it, it breaks up into 3 bubbles, and actually that allows us to click on the share icon and have access to the left-hand side of the screen. We get shown a share model prompt where we define with which groups we want to share our resource, where right now which groups we want to share our model. We can give them access to read all models, just see it. We can give them access to modify it if we really trust them, or we can give them access to execute the model and get predictions. That would give people that would give you great power in order to give more access and power to your collaborators, or just usage permissions to someone that is part of the more general public, but to whom you would like to give access to your work, you would like to give them access to your model. So the data tab in a model looks like this. First of all, you have the dependent feature or the predicted feature, and listed are any independent features there. And what's next is the predict tab, where you get the chance to either predict or validate. You should bear in mind that the design philosophy has changed between Jaqpot 4 and Jaqpot 5. As you can see there, you can find much less clearly discrete buttons that you can click on. There are mostly smooth surfaces. Pantelis Karajas, who does the design choices, makes the design choices for this, gets really influenced by the latest in the latest trends in design, and I think it makes the result more pleasing to the eye and more usable. Just a comment on that. It also means that you need to be careful where you will find the features. We will see an example about that. So right now, if someone clicks on the predict tab, one can add values here. Just if there are not many, if you want just one endpoint, and one would click on the bottom of the right of the screen, you see a red a start in red font. That's how you would start a prediction. Another way, if you had more values to enter, would be to upload a data set with the required independent features and values. Of course, we give you the possibility to download a template data set, which you can edit in Excel or some spreadsheet, whatever. And after you have added your values, you save it as a CSV and upload it back to us. So you would get a preview of what it looks like, and you would start the procedure here by pressing on these the softly highlighted buttons. So you get information about where the about the progress of the task, and luckily and hopefully every time you will see these two arrows here, those two tick marks, and you can, if you move your pointer, you can see the view prediction there, and you see the predictions here along with the values that you gave in. Here our endpoint was the log s exp, the logarithm, and you can download the values and as a predicted data set, and this is what it would look like if you try to view your predictions. The final discussion here tab, this gives you a space and the capability to have an interaction with users about models that you have created, or interact with others that you are working with on the same model. So one could say that this is a social network of models where you take models out of the paper, take models out of cold data sets and cold descriptions, and you give them a possibility, you give people a possibility to interact and finally judge the model. This is actually, the way I see it, the only way to make make safer conclusions about the suitability of and the prediction ability of models. Actually using them and interacting with people, harsh criticism and constructive criticism can be can be accommodated in this implementation. This is someone's user profile. One can add any one should add relevant, not any information, and of course so some other information that people can find you and interact with you, know what you're working on. That is accompanied with your quota, which would give you specific um, um, limits in terms of models, in terms of reports that you can have, in terms of tasks that you can run in parallel. As we please remember, we said that they are asynchronous tasks, they can run in parallel. So in order to not to crash the server, we need to make sure that everyone has a limit to make sensible use of any resources here. If we take a look at the organizations, one could view the OpenRiskNet organization, where we have who we can contact about this organization, and this is the organization page. We see some members here. We see who the contact person is, and actually. What's more important here is where that you can share resources through, you get a notification bell here where you can you see what has been shared by others with you. I got a notification, for example, that I had a model shared through the OpenRiskNet organization from this user, Sarimveis, within the OpenRiskNet organization, and the name of the model is this one. And if I clicked on view, this is what I would see. This is similar to what we saw before. It is another model page where we see the model information in PMML format. And it is a nice chance to see here that if you click the droplet here, you can change between two color themes, which makes it easier for you to find something that is more pleasing to the eye. If there's something that you will be working on, which is what we hope you will. In terms of data sets, the concept is similar to models. Right now, I didn't have a data set, but I did have shared data sets with the lab of process control and informatics where I work. If I wanted to upload a new data set, I would go to the bottom, to the top right of the screen. I would choose a data set. I would choose an ID for the data set, which sometimes makes sense to make it your endpoint, the name of your endpoint, or or none if you choose to do so. The next screen allows the user to add the title, add the description, where you got the data from. The subject, any tags that you would like to do to make it more searchable, and also for all the features, the column names, let's call them, that would allow you to add a description, add the units of measurement, and any ontological information that you would like to be added. Successful creation leads you to this screen. You get the idea of the data set, and I've also added a nice picture to personalize it and make it more appealing for me and others to work with. So this is what a dataset page looks like. Please bear in mind that this goes flawlessly, that this goes without much effort from the user. Someone who has a CSV file and has rather limited working experience with this kind of web pages or general web pages will not have, as we hope, much trouble to log in and do this work. So you will be making your dataset available to others, which is a crucial step in the recognizability of your work. So the data tab, as we saw in the dataset page, is the next tab. We see the features that are added here, and there's also the discussion element here, the discussion tab, where people would have the chance to discuss on this data set. People could leave a pointer and say, okay, I have used the method X and achieved this accuracy. Please see more details in my model. Then there would be a discussion, what parameter values did you use, or discussion on the ontological annotation. There needs to be a space where this sort of scientific discussion can happen, where all users are, where I can click on users and see that they are valid, they are scientists. We need a space to be able to make these discussions. Right now we see Jaqpot as it is in the EOSC catalog, the European Open Science Cloud. It has been added there, and it is we intend to expand this the offering of Jaqpot, and it is a great honor for us to be included in the European Open Science Cloud and have contributed our work to the open science vision. What we would like to show finally in for about the work of Jaqpot 5. I'm trying to make this a little bigger, but not too big, because some cells produce a rather big output. We will be showing how Jaqpot Pi can work, and actually this is an example where we will be integrating tools from two partners here. This is the exported view of a Python notebook, of a Jupyter notebook, where we start by getting the blood-brain barrier dataset from the Lazar tool, which is a part of OpenRiskNet. I've highlighted here their URI, and if you wanted to access the tool yourself, you could take a look at the Lazar tool as it is there. But the request, and as it works, this is how it looks. So you get a message, a 200 message means that everything went all right. And I don't have time to go into the details here. Sorry, I have to move on a little faster. But what we got from the Lazar tool is this. We got a dataset that shows the smiles of each compound and the result for the blood-brain barrier penetration. Please remember that this is the same dataset that we saw before, the one that we asked to that we uploaded before to the Jaqpot 5. So this is our dataset with 415 rows. We will be adding additional descriptors calculated by the ModelRX package. The ModelRX package offers around 1,825 descriptors. Depending on what the implementation is, what you actually use varies, but you get the calculations very easily. Some compounds have smiles that cannot be processed. These are the ones in our case, but for the 388 compounds that are remaining, we get the results in less than a minute. Of course, that the time depends on the dataset that you use. For the LTKB dataset, for example, if you try to do the same thing for 930 compounds, you could get something in the area of 10 minutes, not 3 if you did it, if you try to think proportionally. Some compounds cannot be processed, so we remove them. Some need to be converted to a smaller size floating number. So what you end up is here you get some pre-processing. You get rid of values that make no sense. You join the initial dataset with the one that has the descriptors with it, and a good thing is, in this case, a necessary step is to use the label encoder in order to convert the text, the strings that we had penetrating or non-penetrating, referring to the blood-brain barrier. So it's constructed as a 0-1 case here, which is much easier to process. And we also perform scaling on the data set. So finally, we start performing some modeling, and we will be In our example, we will be using recursive feature elimination to go from 748 features with a small sacrifice in accuracy. We will be reducing it to 20, which will make the data set much easier to view and understand for our description. And this is our list here of the features that were chosen. This is the accuracy that we have, 75%, if we wanted to take calculate it over the whole data set. And the nice thing that we've all been waiting for is here. In cell 53, numbered as 53, depends on the time that it was executed, it doesn't mean anything else. We see the implementation of the usage of Jaqpot Pi. So we import from the package Jaqpot Pi, Jaqpot, and we make a request where we add our username and password, and what we get is a Jaqpot deploy pipeline command. For those who are mostly experimental, please bear in mind that this is something that refers to this implementation here, where you can use any method from scikit-learn and change the parameters. And with this call here, what you get is you actually deploy with one command your model. You give the X values, you give the Y values, some information on your data set, and you get back this. This is the ID of the data set. And if you want to implement it, then you go Jaqpot predict, and you get your predictions and the URL of the value. This informs you of the status. And finally, when it's done, we can take a look at the values of the variable. These column here is what we've done the work for, is the blood-brain barrier penetration values that we need. This is actually our prediction. Going back to the presentation, one last question. After having seen all this, please let us know if you're interested in deploying a predictive model through Jaqpot. This is our question. Thank you, Thomas, for firing up the question. I really trust that everyone has answered in good faith and, of course, in free will, because elections with 100% conclusion are usually not free, but as you have answered freely, I trust that we will be hearing from you, and this is a nice thing. I hope we have made a good work making something that you would like. To conclude, Jaqpot is an open source web infrastructure that is characterized by flexible structure. This allows you to generalize across disciplines. What we saw here is an implementation in predictive toxicology and risk assessment, but it can actually be generalized for other uses as well. Very easily. It can be integrated to third-party tools in order to fulfill the modeling needs on the cloud. This would be mostly done with the API, the application programming interface, or with the integration from within Python. You have visa integration to diverse architecture, ontologies, and knowledge domains. And the Jaqpot offers you a seamless way to take your models out of the desktop or the paper and automatically make them available as web services via the URI. This will aid greatly to having the scientific work more easily tested, and it saves people hours or days of work to see what the researcher has done. Automatically, if for a paper you accompany it with a Jaqpot model URI and the datasets, then someone else can use them as well. And functionality is provided both through API and graphical user interfaces. And Jaqpot is a universal platform that both exchanges and produce datasets that are semantically annotated and employs machine learning techniques to generate predictive models. Thank you for your time and attention. Please let me know if you have any questions. We have time, a little time for that. I think you can raise your hand in the chat, or raise your hand, or post any question in the chat.
Okay. Thank you very much, Philip, for this presentation. It looks like that everything was so clear that there are no questions left.
Or people are just speechless. Yeah.
You made them speechless. That's the other possibility. We are always, as I say, after every of these webinars, we are always open for questions. And if you want if something is coming up, please contact me or Philip directly. And we will be happy to interact with you on that. And since you are so interested in building models, I hope that this is now going ahead and we will have a huge amount of nice new models in Jaqpot. Thank you, everyone, and hope to see you soon in the next webinar.
Thank you. Goodbye.